Using Excel to construct a confidence interval estimate of the population mean. This video uses the example titled Confidence Interval Using Birth Weights. The sample data has been entered in cells A1 through A15 in the worksheet. Constructing confidence intervals in Excel requires the XLSTAT add-in. Note that the Excel function confidence.norm should not be used. It's also important to note that XLSTAT requires a list of original sample data and does not work with summary statistics alone. If only summary statistics are available, the Excel function t.inv.2t can be used as described at the end of this video. To use the XLSTAT add-in to construct the confidence interval, begin by clicking on the XLSTAT tab in the ribbon. If XLSTAT is not available, it must be installed. Instructions for installing Excel add-ins can be found at the website www.triolastats.com. Click the Parametric Tests button in the XLSTAT menu and then select One Sample t-test and z-test from the drop-down menu. The One Sample t-test and z-test dialog box now appears in Excel. The blinking cursor indicates the input item that is currently selected. Click on any input item in the dialog box to select it, or press the Tab key to move to the next input item. For the first input labeled Data, enter the range of cells that contain the sample data. In this example, we enter A1:A15 since these cells contain the 15 birth weights. Cells can also be selected by clicking on the first cell in the data range and dragging the cursor down to the last cell in the data range. Under Data Format, select One Sample. On the right side of the dialog box, check the Students t-test box if the population standard deviation is not known, as in this example. If the population standard deviation is known, which is rare, check the z-test box. If the first cell in the data range includes a data label, check the Column Labels box. If there is no data label, as in this example, uncheck this box. Select Sheet to display the confidence interval on a new worksheet, or select Range and specify a cell to display the confidence interval on the current worksheet. We select Sheet. Click the Options tab near the top of the dialog box. In the Alternative Hypothesis box, select Mean 1 does not equal theoretical mean. The selected item is highlighted in blue. For the next item of theoretical mean, use the default value of 0. In the significance level box, enter the desired value. Enter 5 for a 95% confidence interval. Click OK, and the confidence interval is displayed in the results. In this example, we are 95% confident that the confidence interval limits of 29.247 hectograms and 32.486 hectograms do contain the value of the population mean. As mentioned at the beginning of the video, Excel cannot construct the confidence interval using summary statistics alone. If only summary statistics are available, the Excel function t.inv.2t can be used. In an empty cell, enter equal t.inv.2t open parenthesis. First, enter the significance level. In this example, we are constructing a 95% confidence interval, so we input 0.05, comma. Next, enter the degrees of freedom. In this example, we have 15 sample values, so the degrees of freedom equals 15 minus 1, or 14. Close parenthesis and press Enter to get the critical t-value of 2.144787. Using this critical t-value, we can now calculate the margin of error as described in the textbook. This margin of error is calculated to be 1.620 rounded. The confidence interval can be constructed by adding the margin of error to the sample mean to get the upper limit and subtracting the margin of error from the sample mean to get the lower limit. In this example, the confidence interval is calculated as a sample mean of 30.867 plus or minus the margin of error of 1.620. This yields the same confidence interval limits found earlier of 29.247 and 32.486.